Wait for somebody to show up here on this totally random impromptu live stream in the shop here on this toasty afternoon in June. All right, we got two people. We have a live stream now. So I can't see who all it is unless you comment. So I'll throw that up there. Hey, Bob. Afternoon. Glad to have you here on this totally random impromptu live stream in the shop. I spent the morning making a couple of sheaths and finishing a knife handle and making a couple of sheaths, getting a couple of knives ready. Hi, Marcus. Hi, Eric. And so now this afternoon here, my goal is to forge this billet, this Sanmai, it's a stainless Sanmai billet, out into three small EDC knives of the new design that I have right here. This is the template. So that's the goal. Hi, Al. Thanks, everybody, for tuning in randomly here. Figured, you know what the heck, might as well. So get the forge going here. The angle is not maybe the absolute most opportune, but hopefully you can kind of see what's going on here. Daniel, got a couple people from the UK. So that's nice. Across the pond there. One from Germany. So this must be the time of day when everybody on the other side is able to tune in. Other side of the globe. See if I can move my camera around a little bit here. So I'm running the 2-burner forge here. This forge I actually relined with soft fire brick and then some pieces of ceramic felt on the sides and one on the top just to help out a little bit. So I did a reline on it and it works better. Gets a higher temperature, less fuel than the original forge design. So that's been kind of handy. All right, so again, this is a stainless steel Sanmai billet. The goal is to forge it out into a bar to get 3 of these guys, which is a design that I put together. And it's not, it's not something crazy or different, but I actually went to the grinder with a piece of steel that I forged into a general shape, and I ground out the lines. Sometimes I'll try to draw knives out by hand, sketch them out. Sometimes that works, but a lot of times, literally just sculpting it on the grinder or partially forging and partially grinding it to where you can actually feel where the lines are works better for me than trying to draw it does oftentimes, I find. So that's what I did on this one. This is a template of the original. Hey, Duck Rabbit, how's it going? And then Fuel Power Forge, how you doing? And KK, north of Scotland. So we got another somebody from across the pond again, watching for years. I appreciate that. Bob's in Minnesota. What's the temperature like in Minnesota? I know it gets humid there. It's been warm here and a little bit humid, and I'm not a fan. The heat's one thing, but you add a little bit of humidity, and I feel a little skeptical of that. Hey, Austin, how's it going? Yeah, drawing at the grinder. I don't know, it just seems to work better for me usually. Anyway, so this little EDC feller, so I made several small sand mine blades this last couple of days. I can't remember what day we're in, but I guess I finished them up early this week, and I misjudged the amount of material that I needed, and so I ended up with smaller dies. I ended up with a couple that were about this size, but I was trying to go for this, and I made smaller dies. So I'm still trying to make the EDC design. So that's the deal here. Playing Mario Kart. Yep. Good old Mario Kart. So better get this thing greased up here. Move you guys over here a little bit. Maybe see how that works. I'm just running this on my phone, so we're not getting any awards for cinematography here. Let's get the old beast oiled up here. All right, cool. So I was thinking about this sand my thing. That's been a bit of a process figuring that out, and it's coming along. But I've been debating about how to do this little EDC blade. Obviously, the sand mine mill is forge welded, and then I've been cutting an angle on the billet, and then forging out the edge so that we've got that continuous steel instead of a cutout. I know a lot of guys with their stainless sand mine, they don't do much forging after the forge weld process. And I think from what I understand, sometimes that's a fear of the billet separating, getting a delam on that. which I'm not an expert at it by any means, but if that's happening, you might not have a secure forge weld. I mean, I know that, even a really good forge weld can come apart under extreme circumstances, but forging at a proper heat, I don't think that should happen. I haven't had that happen. And then the other concern is when you quench it, that stainless steel will try to pull apart the actual core steel and create a hairline crack or worse. And I have had that happen. You can grind them out if it's not too deep. So that's a concern. And something you have to pay attention to. So, this whole stainless steel thing, there's there's quite a bit to it. Stainless steel sand my deal. It's not just a simple matter of sticking together some pieces of steel and making a knife out of it. And so sometimes you'll see comments on here from people that, make a comment, and this isn't a disparaging remark, but it's like, well, you probably wouldn't ask that if you understood what you're talking about. And listen, most of us don't know what we're talking about when it comes to something, and that's okay. There's nothing wrong with not knowing what you're talking about, but the problem is if you think you know what you're talking about, but you really don't. So I try to be careful of that. I don't want to be one of those people that, and I'm sure I have been before, but I try to pay attention to that. I don't want to be somebody who doesn't know what they're talking about but thinks they do. That's kind of annoying. CJ made a living out of not knowing jack squat. Well, I wish more power to you. That's a skill in and of itself, right? Appreciate you watching. Glad you like the content. So yeah, this billet's heating up pretty good, and I'm gonna set you guys up over here. Hopefully, the phone doesn't fall down. But I guess we'll find out, right? I don't know. We'll see. CJ, Broadback air hammer. I haven't seen the Broadback. I saw Coal Iron is making their own air hammer now, which I thought was kind of interesting. Yeah, yeah. Politicians in general, huh? That's a fact. I'm not going crazy on this, but I am forging it on the edge, narrowing this down. We got to draw this out, and I feel like it should, and so far I haven't had any problem with it, but I feel like a billet should be able to handle that once the forge welding process is complete. And so, if you have to baby it so much just to keep your welds together, then that, in my opinion, that's not a very good weld. So what I'm doing here is a sand mine where we have two pieces of 304 stainless steel and a 52100 in the middle. And the most difficult part of the process, well, the two things I guess I mentioned a minute ago is the actual forge welding of the stainless steel to the high carbon steel. And then there's issues with keeping it from pulling itself apart after the quench. And so there is some differences for sure. Anytime you have any kind of a laminate or forge welded billet, though, you're adding a certain level of complexity to the project rather than just a piece of mono steel. So there's more variables. So Patrick, you did 5160 and 304. Patrick, you said you had a lot of warpage. Curious what you might have quenched it in, and if you used an interrupted quench. Can't really tell what you guys can see. Is that, I guess it's fairly visible. Got a lot of the ceiling in there, which is not really that helpful. See if I can put the phone down on the anvil here. Okay, so use a plate quench. Well, I will say that out of all the steels that I've used, 5160 for some reason likes to be a little more cantankerous with warpage out of the quench. I don't know why. That's just been my observation. So maybe that has something to do with it. I don't know. It, you know, it being a deep hardening steel, it's really got that. It's got that going on. So put you down here for a minute. I thought that might happen. This is kind of a redneck operation here, guys. So, what you see is what you get. At least I got my Christmas lights, though. So yeah, update on the power hammer. I'm still having trouble with my interchangeable dies, and the biggest trouble I have, I think, is after I interchange them. So if I switch them out for the drying dies that I have, once you take those bolts out, because I talked to Dave over at, there we go again. I talked to Dave over at Little Giant, and he gave me kind of the methodology on how to get those bolts to stay tight. And you put new bolts in, you tighten them up, run the hammer a little bit, and it's, cinch them down again, because there's always some stretch in a bolt, and you gotta let them stretch a little bit and then take that out. And then in general, a bolt's gonna stay tight after that. But then the problem is that once I took it off and put some different dies on and then put the other ones back on, you've lost that. You've lost that set, and the bolt's stretched out now, and you can't redo that process without using a brand new bolt. And so you're just left with tightening it up, and eventually they break. So that's kind of where I'm at. I think at this point I'm going to go ahead and get a solid die for the top, because that's where my problem is. I mean, the bottom die loosens up about 1/10 of the time, maybe, that the top die does. And so it's just sitting there anyway. It's not going to fall off. So it's not a big deal. Jay, yeah, I did think about lock washers, and I haven't tried that yet. But my suspicion is that it's not going to solve the problem, just based on the force, the hammering. It's not. I'm not confident that would solve it. I should probably try that before I spend the money on a solid die. I probably will, but we'll see what happens. So yeah, I appreciate you guys hanging out while I get these knives forged out, starting by forging out the stock. We're going to go back up here. Got my fan running, my little fan. turn on my big fan, but I don't know if that'd be too much noise for the live stream. So we'll just survive with the little fan for now. As long as you got a breeze going, you can kind of keep your body temperature from getting too hot. Hydration and breeze. So if you're just tuning in, this is what we're going to be working on. This is, well, I'm gonna forge them out here on the live stream. That's the goal, and then there'll be a lot of other steps to complete, obviously. But this is my template, my pattern. This little EDC knife and stainless steel sandmai. There goes my top die again. Hey, Steven, appreciate it. Thanks for being here and supporting the channel by watching and everything. Appreciate it. CJ, who's asked who are my inspirations as far as bladesmithing go? Who do I watch? Well, I think you can learn something from almost anybody. So what I try to do in my craft is I try to look at specifically, and I guess this is probably what you're asking who this is, but just to clarify, I specifically try to look at people that are beyond my skill level, or what I feel is outside of my range of ability currently. And I think that's important because that helps push you to the next level. So who is that? So for example, Kyle Royer, everybody knows Kyle Royer, and he's a big name in bladesmithing, but he's not the only one. He just happens to be somebody that's put his stuff out there a lot, specifically on YouTube, and so you can watch him do his work. But he's very good. There's a lot of other guys that are very good as well. Their work is a little more difficult to access, but I think, so he's one. And then somebody that I've learned a lot from over the years is Kevin Cashin. And I know there's different resources out there and stuff now, but it didn't always used to be that way to the extent that it is now when it comes to heat treating and metallurgy, things like that for the bladesmith. And Kevin Cashin has been somebody who's had a lot of great resources on that, specifically on the metallurgy and heat treating and stuff for years. And I've learned a lot from him. He's also very good just as a bladesmith too. So those are a couple of guys. So Kevin Cashin was probably the first guy that I really kind of tried to learn from. And then in more recent times, when it comes to the aesthetics and fit and finish, that kind of thing, definitely Kyle Royer. But, that's the other thing, too, is different bladesmiths have different strengths. And so, those two guys that I mentioned they have different wheelhouses, really, I think. And so to get a well-rounded education or understanding, there's a lot of different guys out there with different wheelhouses or areas of expertise, even though they might be pretty good or really good in a variety of areas. They have one or two areas that they're specifically focused on. Does that make sense? So anyway, to answer your question in a very long-winded fashion, those are a couple of guys that I have specifically followed for quite some time. And then there's a lot of others that I like Bert Foster. His stainless steel sand Maya, I've kind of looked at that as inspiration with pursuing that. And he's been doing that for a while. He's another master smith. There's others. I can't think of any right off the top of my head right now, but I know I would if I walked away and came back. But anyway, there's a couple of guys. So hopefully that answers your question. So Plectrumura, I'm not sure if I said that right. What's happening? What's going on? Oh, you just moved so you can build a shop. That's awesome. Appreciate you watching. Yak fishing, appreciate it. Thanks. I'm glad the content is useful or helpful. Kyle Royer's fit and finish is definitely aided with things like a milling machine. They're not necessary, but they certainly make it much easier. Am I wearing pants? Yes. As opposed to shorts. Yeah, man, appreciate you watching, and I'm glad the content's useful and helpful. Yeah, it might be hot. It's not that hot. So the finished spine thickness that I'm going for on these EDCs is a little thicker than I normally would do with this stainless steel sand bar. I'm going for about a 9/64 finished thickness, and I know y'all gonna complain about the Imperial system versus the metric system, but sorry, that's just the way it is. Duck Rabbit, yeah, Larry Thomas, but like I say, before Larry Thomas, like he's compiled a great resource, but like I say, before he was popular or doing his thing, there was other research. It was more difficult to come up with the proper and relevant information. Hey, Miguel, how's it going? Yak fishing tire hammers. I don't think they're any worse or better than any other type of mechanical hammer. I haven't used one, but from what I've seen, if that's what you can get, if that's what's available, it would certainly be a heck of a lot better than just doing it by hand if you've got a lot of hammering. So we're getting it drawn out, getting a little closer to where I want to be before I start cutting my blanks out. But yeah, I mean, on that note, the only Lord and Savior is Jesus Christ, but I know what you mean. Fling shot, I am in Texas. Hey Cody, how's it going, man? Yeah, you gonna make something out of that old saw blade? Oh yeah, I don't know, maybe you already have. Yeah, how's it going, Cody? I hope it's not as hot where you're at as it is here. Probably not. You got better temperatures. The OG Frenchie. By Texas standards, I don't think it's hot yet, but it's warm. Close to where I want to be because I want to save some forging after I cut these. I don't know. Probably get it a little bit drawn out a little bit more. So something I do want to do is I want to make it a little wider because on these billets, I am sealing them up with the arc welder, which is a necessary part of the process prior to the forge weld process. And I've ground that off, but I've noticed that, well, maybe this has nothing to do with the arc weld, but there's a little bit of oxidation that happens right at the layers, and so I want to have a little bit of extra, which you do anyway for oxidation and stuff, or decarb. Anyway, I don't know what I'm saying. Point is that I want it a little bit wider. So the goal is to use this material to get 3 of these. And to do that, we're going to have to do a tapered tang, which is fine. Yeah, CJ, 88 with 17% humidity. I don't want to hear about that. You just keep that to yourself. How about that? How heavy is my primary hand hammer? Well, got a couple here. This one is about 5.5 pounds. And then this guy is, I want to say it's like 3.5. Well, I don't know. I don't know how heavy this one is. It's lighter. I don't use this one quite as much since I got the power hammer, but used to be my go-to because when you're doing all the forging by hand, it's not like it's not like a super strong thing where you're like Thor or something. It's like twitch muscle memory, that kind of thing, and you get to where you're trying to make the hammer do more work than it's really designed to do, and you're slamming it down. It's like, hey, if I had a bigger or heavier hammer, it could do more of the work. And so that's how I eventually worked my way up to a 5.5 pound hammer. But that's really probably not necessary for most people. Duck Rabbit is mercilessly beating his kids in Mario Kart. That's called good parenting right there. So I better check my thickness here. John, Newfoundland, how's it going up there? So we're about only got 16ths on here. I got to do math. Hold on. This is terrible. 7:30 seconds. Is that right? Yes. 7:30 seconds thick. That is still too thick, which is fine. That should be about perfect to thin down. And as I thin it down, it's going to widen out, which is what I want also. So kind of dancing the line between oh, sorry. I thought you said you were playing with your kids. Sorry, man. Duck Rabbit. All right, your brother and cousin. Never mind. Well, if you did have kids, that would be. I must have misread that. I thought you said you were playing, but I don't know why I thought that. Sorry, man. All right. Jeff Rose, Ohio. How's it going? Well, get good at Mario Kart, so when you do have kids someday, you can beat them on it. What was I saying before that? Oh, yeah. So kind of dancing the line between material conservation and time conservation. Sometimes you can spend more time trying to save as much material as possible and end up wasting time doing that. Okay, so at this stage, I'm just going to keep thinning this down. And as I do that, it'll also widen out a little bit. I might widen it out a little bit on purpose too. So I think we'll have enough material to do 3 of these with a minimally tapered tang, which is kind of what I want because, as I was saying earlier, I'm doing a little bit thicker spine on these than I would normally on a knife this size. Normally, this would be an 1/8 of an inch thick blade. With these, with the stainless stand by, it can bend easier, and so I want a little more rigidity, and I'm going to gain that through a little more thickness. But also, that also affects how you grind the blade and the reveal of the carbon steel. So there's a couple different reasons for that. Mike, Washington, good old Washington. CJ, the ribbon burner is working great, and it's everything I was hoping it would be. And that's how we're doing all this stainless steel sand by now, so it's been great. All right, that's two drop forges right there. I've completed the required number of drop forgings for this piece so we can continue on. All right, well, I don't want to push it, but yeah, we'll probably just get 3 out of this. Steven, I thought I was going to move back to 902, but plans changed. And the basic situation is real estate's super expensive there, but God's been working in the meantime, and it's been fruitful to be where we're at. So there's, you know, more to it than to just wanting to be in Idaho, but who knows, maybe someday. OG Frenchie, so I used 416 stainless on actually the first stainless San Mai that I did a little bit ago, and I used I think I used 125 CR1 on that one, but it works. That's the only time I've used it. It worked fine, and it should work fine with 1080. From reading that I've done, a lot of guys don't like 416 because 416 is designed for a machining steel. What I'm trying to say here is it's got a higher level of sulfur in it to aid in the machining of it. If that makes sense, make it more machinable. And so that sulfur content can create like inclusions or even like cracks in the steel apparently. Like I say, I've only used it one time for stainless steel San Mai, and I didn't have any issues, but apparently it's not great for forging. Hold on a second. So the 416 apparently is not the best option, and so I did some research because out of the 400 series, which is a Martin Citic stainless steel, there's also like 410, 420. So other lower carbon, they're not plate steels still, but I was looking at those and they are, compared to the 300 series, are very expensive. And that's why I ultimately chose to go with 304. The 304 series is an austenitic stainless, meaning that even at room temperature, it never converts from austenite because there's so much chromium in it and so little carbon as compared to normal steels that it can't move, like it stays austenitic. So that means it doesn't harden. The 400 series is going to harden a little bit, not like a blade steel, but it's going to be stiffer. And you know, if that's what you want, that's what you would choose. But anyway, if you have 416, you know, yeah, go ahead and use it. It seemed to work fine, but I guess it can cause problems in the forging with that sulfur content. So hopefully that answers your question. Yeah, so if you already have it, the 416 and the 1080, those should work fine. And I guess there's guys that have used 416 for quite some time, but it can cause issues with the sulfur, apparently. Shorty, how's it going? I keep having to really carefully read your name. Plectrum Rumra. Sorry, I don't know. Zero atmosphere. Yeah, that's important. So I guess if that takes some time practicing, just laying down a nice consistent bead with your welder, maybe playing with some of the settings on your welder or something so that you can do that, that'll definitely be useful in completing a successful stainless semi forge weld. Hey, Aaron, Oklahoma, land of the tornadoes. I'm working on stainless steel sand my billet. I'm going to be making some little EDCs out of it. Right now I'm just drawing it out to get my lengths out of it. I think this is, spin a little bit there. I think that's as far as I'm going to go. That's what I want right there. So, so we should be able to divide this up into 3 equal parts, all of which are going to be too short for the finished knife, but we'll just draw out the tang end nice and tapered. Give ourselves a tapered tang and get the appropriate length for our knife. Pardon me while I tighten up my top die again. CJ, what? Shorty says I got a spammer. Okay, where? Oh, CJ. I'm backing up here. You don't use flux on stainless steel sand my. It would, from what I understand, it would require an extremely aggressive flux. It's just much easier and better to use to create a no atmosphere. No, it's a different CJ. Sorry. Yeah, we use flux for the carbon steels. But sorry, I'm trying to answer multiple things at one time. Yeah, flux for stainless steel sand by is not really a viable or practical option. And so sealing it up for 0 atmosphere is the standard way the guys do it. And that's what I'm doing. It works well. Sorry, I can't see your name. Trick to the heat treat so you don't pop a weld. The bigger issue is popping apart the actual core steel because of the different contractions of the steel, which would suggest that obviously your weld is good. But again, just using the interrupted quench instead of quenching down to ambient temperature, that's going to be, I think, that's going to be one of your biggest advantages to keep from destroying your billet in any manner during quench. Hey, Tinkerist from the Netherlands. Probably butchered an accent on that. Okay. All right, well, I'm going to mark this billet here into 3 mostly equal pieces. Well, what I'm trying to do here is oh yeah, okay. Well, it's hot, so I can't really grab it for one thing. But what I'm trying to do here is make this more complicated than it has to be. Not really, but I want to cut it at an angle here so that I can forge up the tip of the knife. Okay, and then we've got a flat side here and a flat side here, but the piece in the middle is going to have an angle on both sides unless I cut that off flat, which means there's some lost stock in there. But again, I think I'm overcomplicating it, so bear with me, please. Please. So 5 inches, that'll work fine. It doesn't come out exactly, which is slightly annoying. Close enough. Now I just have to remember which lines I'm using. You ever do that? Give yourself like 4 lines. What's that they say? Cut twice, measure once. No, see, that's not. That ain't right there. Okay. How long have I had my power hammer? It's been a couple years now. And somebody asked how old the power hammer was. It's 1927. So let's see here. Yeah, that doesn't leave as much material in the middle as I was hoping. So, instead of trying to cut the angles on the bar, we're just going to cut this into 3 equal pieces. I told you I was overcomplicating it. Trying to minimize the amount of cuts I actually had to do, all that kind of stuff. But I'm just going to cut it into 3 pieces and then cut my angles for forging up the tip. And then I don't have to figure out how to do all this stuff. So there you go. So you can see the template here and the length of steel we'll have to work with. We've got about 1/3 of the handle length to draw out for a tapered tang. So that's not too bad. Okay. Okay. Patrick says he has a 1/2 ton of 410. But it's shafting. Yeah, you can forge it out. Yeah, just get it to a good forging heat. Yeah, definitely forge it out. Let it cool down. Should not be a problem. I'm not aware of any issue as long as you forge it at an appropriate heat. Oh, gee, Frenchie, if I had to start from scratch, would I buy a power hammer or press first? Definitely I would go with the press first unless you can afford a large hammer. That's my answer. And I've, based on experience and thinking about it a lot, that's what I would do if I had to do it over. So I got to pull out the old cut off peel up so it's hang tight. Anyway, I could explain why that's my answer about the press versus hammer. But that's my answer on that. In short, it's because unless you get a large hammer, you can't do what I'm trying to say. A press cannot do everything a hammer does and vice versa, but a large hammer can do the most of both, I think. If you get a small hammer, you're not going to be able to forge big billets. And it's really great for the forging of blades and stuff. But a press can actually do both. It's not as good at forging out thinner stock, but it can do it. It's all about the dies you're using. And it works really well for the big billets and stuff. Well, let's see if I can bring you in on the action here. I think my internet will still work there. If not, then okay, we've got 3 pieces to the billet. Sorry, I keep spitting. 3 pieces here. Now I'm going to cut an angle on all of them so I can forge the edge up. I was trying to figure out how to do that off of the bar, and I'm not smart enough to figure that out, so I just cut them up into 3 pieces, and we'll do it that way. All right, so this is going to be the edges. There you go. Let's go get these back in the forge. Patrick, yeah, go ahead and shoot me a form on my website. It's the best way to do that. I guess there's an email on the channel here too. You can click on that. KK says I get forge blind and grinder blind. I have not had that. I'd be careful with that though, because if it's that bright, I don't know, maybe you have a sensitivity. I don't know. You don't want to mess up your eyes though. I know when the forge is real hot, like if you're the upper ends of forge welding temperatures, the incandescent light can you can see like it's it could be detrimental if you were looking at it all the time, and maybe it is a little detrimental. I try to use when I'm forging that hot, like I say with, or not, I didn't say this, but that's an expression, I guess. With the forge welding, the stainless steel sand you have to forge weld hot enough so that when you look in the forge, I mean, just by the way, that is hot enough. So when you look in the forge, it's pretty bright, and you could, if you were looking at it for a long time, it could probably be detrimental. So you gotta be careful with that. I have some green. You might want to try get some green lens glasses. You can get a clip-on lens. This is what I have, and that will, yeah. Okay, somebody said Didium glasses is out there. Anyways, yeah, it'll help shield that. I use those not really very often though. Maybe I should more, but just forging at normal weld or normal temperatures, I don't notice any issues. When I get up to the higher forge welding temperatures, you can tell it's pretty bright. And if you were looking at it for a long time, it'd be kind of like looking at the sun. However, when I wear those glasses, I can't really judge the temperature. And so I just try not to like stare at it or look at it for any length of time. Okay, so we got to turn 3 of these into that. Well, at least a blank we can. I hope we have enough material there. I'm still kind of in the research and development stages of this particular knife. So we'll see. I'm not feeling quite as confident about the amount of material as I thought I was going to. But anyway. All right. First thing I'm going to do is forge the tips over so that our edge steel comes from the continuous whatever side of the steel instead of just being cut out. Because if you do it that way, it's guaranteed to cut like 1,000 times longer and never break. In fact, you hardly even have to sharpen it if you do it that way. And of course, I'm joking. Fat Bastard Forges. Yeah, I'm working on some sand my blades from a billet that I made, I don't know, a week or two ago now, something like that. Got to make some NAS out of that. Hey Chris, how's it going? Yeah, we've had a pretty good grip the whole time here. That's awesome. Totally unannounced, impromptu. I was needing to get out here. Yeah, you're supposed to forge stuff in the morning when it's cool, right? But I didn't. I was finishing up a couple of knives and getting those up on the website as soon as possible, like I tend to try to do, you know. And so that put the forging for today in the afternoon. Yeah, Chris, it's warm. I mean, like I said earlier, I think it's not quite hot according to Texas standards yet, but it's warm. We've had a little bit of humidity. That's what makes it worse. Yeah, I want to try to bring you guys down here so you can see how I'm doing this. So I'll try to make that happen. I don't know, maybe. I've got y'all. I got the phone stuck in one of the holes in the swage block, so I'm pretty sure they never envisioned that would be one use for a swage block when they built it, but when they cast it. But anyway, excuse me. Question: would you normalize, would that reset the grade structure of alignment anyway? It, to some degree, I mean, it resets the size. The grade that we're kind of talking about when it comes to linear grain, that has to do more with any minimal, and if you have really good steel, you technically wouldn't have any, right? But minimal impurities that create, I don't know what the right word is for it. It's not quite inclusions, but like phosphorus and sulfur. I can't think of the right word, but if they're running lengthwise, that's better for the strength of the piece of steel than if they're running crossways. Now, in modern steel, quality steel, that's far less of an issue than it ever was, 150 years ago. And just like that, you have a ready-made Bowie knife tip. Huh, how interesting is that? I still say that's where that design came from, not from anything else. Yeah, Florida would be hot. Hey, I'm gonna go hydrate real fast. Don't go any well. Hold on, I got something in the forge. Hold on. So in this case, it's kind of dark, but you can see our piece of steel there, and the lighting stinks, but yeah, you can see the steel like that, and then we're just gonna basically take off that clip, but we've got our edge on the tip of the knife fully forged out there, if you can see that. I'm going to be right back. Okay, I'm back. Thanks, guys. Yeah, the grain reset thing, that's what the books say. That once you, heat it up to proper normalizing temp, it's all wiped away. It's all reset. I will say that that's not true based on personal experience. And if you also study traditional forging methods, they suggest that that's also not the case. And I realize that there's conflicting information there. But an example of how I proved that to myself was when I was forging a Chinese style cleaver. It's not a cleaver, it's a knife, but it's a big square blade. And I forged that out of 5200. I forged several actually. I think I was up to like 4 or 5 by the time I actually got the project the way I needed it to be. But anyway, on several of them, I maintained a full forging heat all the way through the process. And then I ran my normalizing and my whatever processes after that. You know, annealing, stress reduction, etc. And I had warpage that I could not correct. I traced the problem back to the finished forging heats. And so on concurring projects, or redoing that project to where it would actually work, I focused on graduated forging heats, at the very least not heating it up past the last forging heat. And so forging it down lower and lower temperatures. And as you get to the end of your forging process, you're barely moving any metal. But I did that and then followed through with my normal normalizing and so forth. And that problem with the warpage and the stresses that was no longer there. Those were eliminated. And so in the previous procedure, I created stresses that I was not able to correct with the normalizing process. And so in some way, normalizing is not just a delete button for everything you've done to the steel. And a traditional forging technique teaches us that also. I'm going to be talking about this in an upcoming Metallurgy Monday when we're talking about grain refinement. But yeah, I realize that is the metallurgist information out there that you're going to find. Based on my personal experience and other information, that's not quite the full picture. And so, if you want to extrapolate that out, it does matter how you forge, which links up to the whole idea that a forged blade, at least back in the day, was a better blade. But again, that really comes down to who's forging it and how they're forging it. But that's just my experience. Yeah, there's some guys that are crazy with those blades. I guess that's what happens when you use one for thousands of hours. The steel I was using was, it's all rolled out of the mill. And then think it's water jet cut into strips, you know, but it's all rolled coming out of the mill. Even the CPM stuff, right? They create a bunch of minute droplets of steel in inert atmosphere, and then basically forge weld those all together and press them into a billet, and then that has to be rolled out into sheets of steel, which are then cut up into the bars that we get. David, I'm working on making some of these little guys here out of some stainless steel sand mai. So we forged out the stainless steel sand mai billet to an appropriate thickness to start working on the blanks. And so now I'm just forging the tips of the pieces of steel. I don't like to use the word blanks because most people, when they hear that word, they think of like buying a pre-made knife blade out of a catalog and putting a handle on it, which is not even remotely what we're doing here. But we've got the bars of steel. Those tongs are still hot. And I'm forging the tip so that we've got an edge that's forged. That's just how I'm doing it. Saves a little bit of material. It's a forged blade, so I'm going to forge that. Bring that down here. Okay. Drop it through the hole in the swage block. All right, so we've got the basic rough shape of the blade tip forged out. So now we got to address the what's going to be the tang. I'm a little nervous about the amount of material that I may or may not have here, to be honest. So what I think I'm going to do, I think I'm going to split the difference, because here's the knife I'm trying to make, and here's our stock, and I want a little bit of extra width on this, so that that could be a little touch and go there. I've still got some thickness to work with. So what I'm going to do though is I'm going to split the difference here, and I'm going to start forging my finger choil or whatever right about the middle. Well, I guess it'd be the middle on this side. Give that for the tang and this for the blade. If we end up with a smaller knife again, so be it. Like I said, I'm still in the research and development stage of this knife, trying to figure out how much stock size I need from this particular stuff to actually make the blade I'm trying to make. Yeah, KK. God, family, country. What's your order? Well, let's start with God, obviously, because nothing comes after that. If you want to have a rational and cohesive view of the world, that's just my opinion. Well, it's not just my opinion, in my opinion. I believe that's what the Bible teaches, but that's my order. So, all right. So I got to get back on the power hammer for this next step here. Yep, thank you. Appreciate it. Plectramura. I think I said it right that time. Have a good one. Appreciate you being here. Ran out of heat on that one. I was trying to get this lock up under that hammer. It's just started running, so it didn't work. I know I'm a little nervous about the stock size we have. So I've got a tiny little, like a tiny D-lamp, but you probably can't see it, right here on the very edge, which I am pretty confident it's just surface level right on the edge of your billet, which is not uncommon. I'm just going to run and grind that off real fast. I think I was forging it a little bit too low of a heat there on one of those deals where I was trying to forge in a finger choil a little bit there. Steven, so yeah, about moving to Idaho, yeah, we had planned to do that, and plans changed. As of right now, really, it's there's multiple factors, you know, but one of them being, just humanly speaking, real estate is still crazy in Idaho. For what we would like to have, is kind of outside of our realistic range right now, but it's still been a fruitful time. So, KK, other than a forge and anvil and tongs and grinder and effort, what's your top 5 bladesmith tools? Well, you kind of named a bunch of them, I guess, but this is just me speaking from my personal experience in my shop, but I will say one of the top things that you need to think about is a way to cut stock for whatever projects you're working with. And, you know, starting out, that might just be a hacksaw. And that's literally what I used for a long time to cut pieces of steel to make knives out of. And then, but, you know, you can use a cutoff wheel on an angle grinder, and you can get a chop saw, and then you can get like a portaband saw, and then you can get a big metal band saw. That's sort of what a progression might look like. But something to cut stock, that's actually really a big deal, particularly if you're making a lot of items. tapering this down. We'll see if we actually can make the length we need for this knife. I don't know. Okay, well, so this is about the thickness that I want to go with. Yeah. That's already just a strong 1/8 inch, so that's, I don't want to go any thinner than that, which means we did not quite achieve the length on this blade that I was wanting to. Very close. I don't know, if I taper the tang out a little more, we might be able to, but I also, this is kind of going the wrong way. But as thin as it is now, it's going to be pretty tough to correct that, so we'll try though. We shall see. Back on the swage block to see if you can see what I'm doing. Appreciate you guys hanging out. Makes it a little less, what's the word? I don't know. A little less torturous to be out here. I put in a long day yesterday, finishing up. Well, getting as close to as I could to finishing up the 2 knives I mentioned. And so, I don't know, a little bit tired today. Let's just say that coming out today to forge at these temperatures felt a little less appealing than it usually does. Which is usually not an extreme amount, you know, but it's all right. I'm not complaining, I'm just saying that's what it is. Well, we might get this real close here. But it's still not quite right because I wanted more thickness on the finished knife. So if you just tuned in recently, what we're doing is working on, I better cool that off here, hold on. working on some of these guys, or trying to. And using some stainless steel samurai stock that I made a week or two ago. Yeah, I don't think we're going to quite achieve that. It's still going to be a great little knife. It's just not quite enough stock to achieve the design that I had. Well, I don't know. It's going to be really close. It's going to be really close. But I'm going to leave this one right like that. Just double check this on top of the template here. Let me see if I can bring it down here and see if I can flip the camera around. Can I flip it around here? Yeah, there we go. So here's our template. This is our stock. And we're just a little short. But it's still going to be a nice little knife. It's just not going to be quite this one right here. So that's just another step on the development of this blade here. So what does that mean? Well, it means I need to figure out what's going to be the best stock length to get a number of knives out of it that I want. And that billet size was totally arbitrary. I just went with, I believe that was a 3.5-inch billet, 3 layers, so 3/4 inches thick by 3.5 by 1.5 wide. And that drawn out is not quite enough to make 3 of these. So, you could say, okay, you could still make the same size billet, draw it out, and make 2 of these and then another little knife, or, which is what I'll probably do, I'll go ahead and make a 3 3/4 inch or 3, maybe even a 4-inch billet, and then knowing that's going to give me enough material drawn out to comfortably make 3 of these guys. It's more helpful to know that than it is to know exactly the dimensions off of a piece of stock, because I don't want to end up with, enough for 2 knives and then a little drop piece. Like, that's not really helpful. So just knowing the exact length that I need for each one of these is not as useful as knowing what size of billet I need to make in the very beginning to get an equal or even, not an even number, but like not end up with just a little bit of stock that I can't use for anything. Hopefully that makes sense. It's hot out here. And I can talk more gooder when it's not quite so hot. I'm also going to skip trying to do a finger choil right at the beginning because I don't feel like that really helped much. And in fact, it actually can make that steel go the opposite direction. Because if you bunch up, if you crush it this way and get a thicker piece right in here on one side and you forge that down, it automatically pushes the steel away from the thicker side, which is the opposite direction. So it doesn't really help that much. Hey Randy, how's it going? Well, I've got a fan going here, so that helps a little bit. And I've got two more blades to forge, so to finish forging, I should say. I'm going to forge the tang out on this one a little more aggressively and see if we can accomplish or get a little closer to our goal of the template here. Well, if you got any questions or anything, just throw them out there. If I don't know the answer, I'll make something up. Not really. So my goal with this is not to not to create an exact profile of this template. My goal is to forge it out to the proper thickness and the general shape so that I can make this out of it. And also, little side note, I think I'm going to leave it in a pretty not rough state. I'm going to leave it more just the general shape for most of the heat treating process, I think. Well, I don't know. We'll see. Because I was talking about this earlier, how on stainless steel sand one of the concerns is having that edge steel actually split because of the different contractions of the two different steels, literally pulling it apart. And there's stress points that are more prone to in like corners and plates and stuff. So I'm thinking about how to avoid that more. Hey, Randy. So yeah, some insulation might be good. So I'm using some stainless steel sand that I made a week or two ago, and we forged it out to some bar stock essentially. And now we're trying to forge some, this template here or something close to that, but figured out I don't have quite enough stock, so they're going to be a little bit smaller knives. But it's a 5200 steel core with 304 stainless cladding. Randy, I have used wrought iron on some sand before, but it wasn't 5200. I think it was 1095 or something like that. Yeah, we don't quite have enough material to accomplish the see that thickness is what I want right there. That's what I wanted to have on all of them, about 9/64. So that being the case, I don't have the length that I wanted. So I could forge this down to 1/8 of an inch thick, get a little more length on it. Maybe I could try to forge in a little bit of that finger choil and reclaim some of that material and push it back towards the tang. See, that's what I was hoping to avoid, though, because that's at this stage of the game and even at the beginning of forging this out, that's pretty tedious and kind of labor intensive. And what I was hoping to be able to do is forge out a blank, for lack of a better word, like this right here, that had the room to finish out to this template. But I didn't give myself quite enough stock, so But again, I would rather have I'd rather have 3 blades that are a little bit smaller than this and still a nice size than have 2 of these and just a little piece of steel that I couldn't use for anything. And so, yeah, I think the solution definitely is going to be, I'm just going to be making a little bit larger billet in the very beginning for these guys. So if I want to do a run of like 6 of them, I'll make a couple of billets that are 4 inches long. And based on all the stuff we've done here today, I know that that's going to be a comfortable amount of material to get these knives out of there. So, yeah, Renee could make a hidden tang, but I've actually passed the thickness that I would want for that. On those, I would have a significantly thicker tang, and I'm already past that. So, also, I'm just trying to develop this particular design. But in general, yeah, that would be a solution. I was using that piece of steel stock to forge the finger choil that bounced, hit here and then up here. Not what I wanted to do. So, yeah. Still going to be a nice little knife. The reason I'm doing all this, aside from just making a knife, is I want to be able to have a process so that, when I say, okay, I need to make a batch of these EDC knives, which I feel like this design is something that I am going to repeat a lot because I believe it's a really good size and design for an EDC knife, and I think it'll be what a lot of people want. And so, since I want to make it out of stainless steel San Mai, I can't I'm not just taking this and putting it on a bar of steel, tracing around it, which that would be fine too. But that's not what I'm doing here. And so it requires a more extensive, research and development aspect to it to figure out how to make that work with with minimal material loss and just general efficiency. So this is our first blade we forged here, and it's cool enough to touch, obviously. So that'll be a nice little knife, nice little EDC knife. It's just not quite the same as what I was trying to make here. It's really close. I mean, the length is just about a 1/4 inch off. It's going to be a nice little knife. Howdy.
I heard you talking about these.
Thanks. Thanks, John. Appreciate it. Well, we got a Gatorade delivery. One of my local viewers stopped by with some hydration, so that was awful nice. Thanks, John. Appreciate it. I'm gonna go grab that. Thanks, John. I'm a big water drinker, but when it's this hot and you're sweating this much, I do go for some electrolytes. Much appreciated. Okay, so that's this guy right here. I think I'm gonna work on the tang just a little bit more, drop that down just a touch in the back. Rudy, what are you doing? We have Germany again. Howdy. So I think this is the longest live stream I've done. Appreciate you guys hanging out with me. All right, so it's still in the rough shape, obviously, but I just want a little bit more of a kick down on that. Well, yeah, if you just tuned in, the goal was to make 3 of these, and I started with a stainless steel sand mine billet that I made a week and a half ago or something, I don't know. And as I explained earlier, I'm still kind of in the research and development stage for this particular blade, and trying to figure out just how much stock I need for a given number of knives of that exact design. And so figured out that starting with a 3.5-inch stainless steel sandmine billet in the very beginning of the process does not quite give me enough steel to make 3 of these. So that's useful information. That means I'm going to start with a 4-inch billet, and everything else in the process will be the same. And then once we draw it out, like we did earlier with this one, that is going to be enough material in those dimensions to make 3 of these. But today, we're ended up making slightly smaller blades. And they need cleaned up still. But anyway, they'll still be nice little knives. Yes, sir. All right, we've got one more after this here. So as I explained earlier, how's it going, Hunter? This is about halfway through the process, and this is the finished deal. But this is our edge. So we forged it from the continuous length of steel instead of cutting it out, since it's a forged blade. And then in the final product, obviously it'll be cleaned up to look like this more of a drop point. So we have one more to do. This guy right here. Thanks, Randy. Catch you later. Thanks for watching. Yeah, I've been pleasantly surprised. I appreciate you guys, because I had to come out here and forge these blades this afternoon, and did a completely unannounced impromptu live stream, which I don't do very many live streams, but we've had a pretty good group since we started, so that's been cool. Either you guys are interested in the process and stuff, or you're just really bored today. Maybe both, I don't know. Anyway, I appreciate it though. Yeah, if you have any questions, throw them out there. see what I'm talking about. Use that 3/4 rod to forge in that finger choil. But you can see how it's mushroomed out now. So when I forge that flat, it's actually going to push the steel this way, which is not very helpful, but that's just kind of how it works. So I'm going to have to defeat that by other processes. And so on the last one, I didn't forge the finger choil first. So I was like, yeah, it's no good. It just kind of depends. I don't know. I'm going to have to do a combination of both. But now you probably can't see it. I've got a little tiny delay right there. I'm confident it's just surface level, but that's going to have to be ground out. The electrolytes are good. This one's almost gone. Trace asks, what's a trade I can learn that will never die? That's a good question. Here's how I think about that. We live in a pretty prosperous society, but there's a hierarchy of needs and wants when it comes to people's lives, right? So my trade is maybe borderline need want, but I would say the kind of knives that I make are more of a want, right? Okay? And there's not a problem with that because a nice truck is a want. Like, do you really need a nice truck to haul your tools to the job site? No, but not getting into all of that. The point is that you want to think about something that will never die, so to speak. You might think about what are some necessities that people expect and or want, and how can you enter a trade that addresses those. And so if you're talking about, I'm assuming you're talking about just trades where you work with your hands and you do stuff, make stuff. I mean, the ones you always hear about, for example, plumbing, electrician, those can either be in like new construction or in servicing, because there's nobody who's living in their house right now that is going to lose an essential piece of plumbing. Yeah, the comment right there. And they're not going to figure out how to get that fixed very fast. Get on the phone, call the plumber. Like, that's just how it is, right? That's the society we live in. And unless things got extremely, extremely bad, that's going to be the standard for a long, long time. So, plumbing, electricity, stuff like that. Okay, so I'm taking a little different approach on this one, which involves a little more hand hammering. But here's my advice, though, is pick something that you enjoy with, okay, you got to have a combination. Are you good at it? Or can you get good at it? Do you enjoy it? And do other people want you to do it for them? Like if you, let's say you really wanted to do plumbing, but you were no good at it for whatever reason, that probably wouldn't work. But I mean, it's just pretty common sense, honestly. But yeah, stuff that, okay, so does everybody need a brand new pickup like they need a toilet that works? No, not really. So that's just another example of what I'm talking about here. I think you get the point. I'm gonna over talk you here. Sorry. Hunter says 25-pound little giant. Any recommendations? My recommendation for you is to contact or at least be aware of the resource that Little Giant is today. So somebody bought Little Giant. They obviously don't make any hammers anymore, but they bought the company, which is all their records, all their, I believe, like blueprints and even patterns and stuff, I think maybe. Whatever was left. But they are now a resource of information on that kind of thing, upkeep, maintenance, restoration. And so just Google Little Giant Power Hammers and find their website. And Dave is the one that I've talked to several times at Little Giant. And if you have any questions about your hammer and how to do this or that, they can help you with that. Yeah, you bet. So there's that. And then just from what I know, I mean, you just got to keep them greased up. It really depends on what condition your hammer's in. If it's been restored, I think you'll be good for a while. If it's not, I don't know what you said, upkeep. Yeah, I don't know what condition it's in, but like the main bearings, for example, those are Babbitt, which is an alloy of soft metals. I don't remember the combination of metals right now, but it's like tin and antimony or something like that. Maybe some lead too. I don't know. But that was a very standard. Babbitt bearings were very standard, and generally speaking, they would be. You would heat the Babbitt up to liquid and pour it with the appropriate like setup. You would pour it around the bearings in sections or whatever, probably 2 sections, and so it would match that shaft very, specifically. That was how they used to do it. There's other ways, I guess, but those will wear out eventually, and eventually will need replaced. And then there's other pivot points and stuff on the hammer that eventually would have to be reworked, but I don't know what condition your hammer is in, so that's probably the best advice is talking to Little Giant. All right. And honestly, I have too much fun like talking and answering questions and stuff when I do a live stream. So if I'm really trying to like get a lot of stuff done, I typically don't do this because I get too distracted because it's just fun doing this kind of thing, Getting close on this one. Yeah, so we've had a couple of rainstorms lately, which is nice. So we really need the water. But along with that tends to come a little bit of humidity. And that accentuates the heat, which some of y'all know. Some of y'all, I'm not telling you anything you don't know. Actually, probably most of you. Getting pretty close. Got this little divot on there. That's from where this was hanging off of the bottom die when I was using that rod to forge in the finger choil. So that's a little bit annoying. So I'm kind of trying to fix that. But it's like, so this is the thing, is like there's multiple different ways to eventually achieve what we're trying to do here. I'm trying to figure out the best way for what I'm trying to do, which is a combination of efficiency and, you know, conserving material. And so, you know, all this kind of stuff, whatever's in what's going to provide the best, what's going to make the knife turn out the highest quality, that kind of thing. All that kind of stuff, you know what I mean? So if there's a process that might save the most material, but it takes way too long, then it's not going to work, because you're not going to end up with a net gain. So basically what I had in mind was trying to have it so I could forge out a pretty rough shape, but we've got our edge forged, and we've got enough material here to take this shape out of it. And then forging this is, you know, pretty simple and efficient. But I didn't have, it takes a little more material. But I feel like the little bit of extra material loss that I will incur doing it this way is a good trade-off. And so that's how I discovered, hey, I don't quite have enough material. If I was forging everything extremely close and bringing it real close down to the finished dimensions, I could probably have gotten my 3 blades out of this stock. But part of the reason I don't want to do that also, not just time efficiency, is I want to make sure we have enough material away from the edge, particularly on these sand knife blades. So not only do I want to make sure we're away from any decarb as per normal, I need some extra leeway just to make sure I can get away from any minor commonly occurring delams right at the edge. You can get that, but it's not a big deal. You just have to grind back, so I want to make sure I have enough room for that. So anyway, this was all, a worthwhile time expenditure to figure out what this process is going to look like going forward when I want to make these knives. So I was able to reach a conclusion as to how to do that properly. And in the meantime, we didn't quite get the knife that I was trying to make, but we got 3, what are going to be 3 great little knives nonetheless. All right, guys. Well, I think I'm gonna wrap this up here. This is our final blade, and we'll bring the finger choil up a little bit and even that ratio out a little bit. But we learned what we needed to learn on this, and it's gonna work out. So. Anyway, I appreciate you guys coming along on this impromptu live stream and hanging out with me for the last almost 3 hours. Really appreciate it. And hope you have a good rest of your week. And appreciate the interaction and the comments and the questions as always. And thanks for watching. So we'll see you on the next video. Take care.